Hi everyone, I am Andrey, Senior Software Engineer at Secured. I am also a co-author and maintainer of React Hanger and multiple other open source libraries. The main goal of this course is to teach you how to properly organize, compile, publish almost any reusable NPM library. As an example, we'll have a tiny version of React Hanger library built step by step from nothing to a fully automated publishing pipeline that follows the best practices. If you're not familiar with the concepts of React hooks, we do recommend you to go and follow up on basics of it. Although, if your only interest relates to library publishing and tooling, you can skip through the next two modules through the React hooks implementation details and go directly to the module named Prepare Your Code for Publishing. In current module, basically next lesson, we will figure out how to work with the course materials. The next module will be all about setting up our development environment, so our linters are checking our code, tests are running, and TypeScript is type checked. A module building a small React Hanger clone will cover a minimal implementation of React Hanger. We won't be including all the React hooks that are in React Hanger library, but if you are into the React, you can definitely learn a thing or two about testing your React hooks, typing them properly, and other considerations you may have while designing an API of your React hooks. In preparing your code for publishing, we will dig deeper into the details that you need to know in order to make consumers of your library happy. We will cover transpilation, tree shaking, bundling, and all the tooling that does all that stuff. We will also learn about module systems because it's a crucial knowledge to have. The last module will be all about automations that you can achieve with GitHub. So changelog generation, publishing of your code to NPM, generating releases out of your changelogs, and that's about it. With all that in mind, you can go to any module you want, or you can continue to the next one. So let's get started. Hello everyone, so in this lesson I'm going to show what setup I'm going to use. I'm not going to explain how to install anything here. I will just give you some guidance what you need to install, and we will go from that. So in this course, I'm going to use the latest long-term support version of Node. So it will be around version 14. Then I'm going to use Git, of course, for version control. I'll be using GitHub. Yeah, if you don't know what it is, Node version manager, if you want to install it and you're on Linux or Mac, I'm highly recommend to use this thing. It's easy to install. You just follow through these scripts and you'll be good. I'm also using it under the hood, to be honest. So next thing, the editor. The editor will be the WebStorm, right? Pretty great, smartest JavaScript IDE, as they said. I don't think it's the smartest, but it's good. It's a very good one. It's one of the best. It's paid. It's $30, but you can get a free one if you will sign up and install early access program. It will basically provide you with the free access to the pre-release builds of our products, means the products of JetBrains. So you'll go there, follow the download link here, and that's it. It's pretty great. It's for free. I don't think you can use it for the any commercial use, but for the learning purposes, it's more than enough. Another editor that I'm not using, but you may install because it's one of the best on the market again, and it's completely free and supported by Microsoft, is Visual Studio Code. Great thing. All platforms are supported. Highly recommend. Even though I'm on the Windows, right, I will be using Linux for my development. Sounds crazy, but if you don't know what it is, there is a VSL in short, Windows subsystem for Linux. You can install it yourself. It's what it is basically giving you an environment of Linux inside of your Windows. So you have a subsystem, right? And it means that I'll have all the commands from the Linux. I'll be able to install Node using, bjet or a curl or whatever, all other these Linux commands that you have in the console. And I highly recommend you to do that. If you're using Windows, it may be complicated, but if you got used to just a Windows setup with the installed Node on the Windows, etc. You can continue doing so. It's absolutely fine. But I'm using this one. I'm pretty happy with it. I think it has a great integration with Visual Studio Code. For WebStorm, it may require a little bit of searching and Googling, etc. So it's a bit more complicated than for Visual Studio Code. But this is what I'm going to use. As you can see here, I have my console. And if I'll run list the files, right, ls, it actually works. And if you will run, let's say, command line here, command prompt, regular one from the Windows, and if you run ls, of course, it's not working. So I'm going to use the VSL. As you can see here in the directory, it also says VSL Ubuntu 20.04, home, blah, 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 project, and then React Hungry course. So empty project I just created. So this is my setup. You can use your own. It's absolutely fine. And let's go to the next one. Okay, so the first thing you need to do, you need to go into the module 1, lesson 1, and you need to copy paste these 3 files. So let's just do that. I just created a folder. I recommend you to do that, the same thing, like a folder for your project. You should put it in some nice and beautiful place, like projects folder somewhere. This folder shouldn't be in the downloads or desktop, that's for sure, because it's dangerous. You can delete it, and you definitely don't want to do that. So what are these 3 files? License is just, legal information that for the open source project, usually it's MIT license. Basically, it says that you can just use this code as is. We don't provide any support or something like that. So just use it and do whatever you want with it. Open source, Editor config is basically a file that editors are reading, and they decide and they basically follow it through your code base inside of this project. So what I mean by that is, if you prefer to have indentation of 2 spaces, you just set it up here and it'll be 2 spaces. And of course, it will not be a tab. So here you can select tab or space, and we will be using space. You can set up the end of line type and all kinds of other stuff. To be honest, I'm not knowing it perfectly from my head. I just generated it once and I'm continuing using it for all my projects. So I recommend you to do the same. And git ignore, of course. For now, our project is not git managed just yet. We will do it later, as it's not really important for us now. This one will just make sure that these files will not be committed into our repository, so they will be automatically ignored. That's pretty much it for these copied files. Next thing we'll be doing is we have to create the package.json, right? So in order to do that, we need to run npm init, and the package.json file will be generated. So React Hanger is the name we want. Version will be 001. Description, let's just ignore it. Entry point, we don't care. Test command, we don't care. Don't care. Author and Rails. You can type in your name here, MIT for sure. And yeah, it looked good for us. Let's check it out. Here we go. All great. We can remove main for now. Description is empty. We will probably add something later. Test, everything is great. For the next one then. In this lesson, we will set up ESLint and Prettier. If you don't know what ESLint is, it's a tool that scans your code on common mistakes, bad practices that may cause bugs, or just checks whether your code follows some preferred style of writing your code. It has a lot of plugins to extend its default set of rules that it has out of the box. It's a default tool for JavaScript and TypeScript projects nowadays. Prettier, in return, is just a formatting tool that automatically formats your CSS, JavaScript, TypeScript, HTML, Markdown, and many other files for you. It follows some opinionated defaults while still slightly configurable. It can be used as standalone or integrated to ESLint via plugin. We will have it integrated into ESLint pipeline because it's just more convenient for daily use. So in order to do that, we need to open our package.json and add all the plugins we need to make it happen. What plugins, you may ask? Plugins for the ESLint. So ESLint supports multiple plugins that extend its core functionality, which is super helpful and amazing. And what we're going to use we're going to use the React app config, which is made of multiple plugins. It's based on, it goes with create React app, and it's great because it's proven to catch only problems that may lead to bugs and ignoring everything else that's related to formatting. That is pretty useful if you're using Prettier. So we need to start off with just adding them as dependencies to our package.json. Okay, so let me explain what all these dependencies are doing. So this TypeScript ESLint plugin and parser, they give ESLint the ability to read and parse TypeScript files. So also this ESLint plugin adds a lot of rules into the ESLint. So it's not only parses them, but also enables some specific to TypeScript rules. Babel ESLint is basically a little bit of extent of our original ESLint parser. So it enables ESLint to use Babel parser for that. What is Babel and everything about that, I will explain later. So for now, I'm not going to dig into it. Then we have ESLint config React app is the one config that I mentioned that is the part of create React app tool, template, whatever, you name it. It's made of 5 of these plugins. So one is flow type. Flow type is the same thing as TypeScript, but it's less popular. It's made of out of, I think, Facebook is the creator of this one. But I mean, we have to install it because it's a dependency of this config. We're not going to use it anyway, but we have to add it. ESLint plugin import. Basically, it's just to, extend ESLint with a lot of rules that are related to import. So you can, do a lot of stuff with that. You can, of course, read about it in the documentation. JS6 accessibility. If you don't know this, A11Y is accessibility, stands for accessibility. Again, it enables ESLint to scan your JSX files and see whether you have any accessibility issues there, so you can fix them. ESLint plugin React will enable ESLint to see and read JSX files, and a lot of React-related rules that you can switch on, switch off, whatever. Same for React hooks. And that's pretty much it for this thing. What else we have to add and we want to add is the plugin Prettier and config Prettier. What config Prettier does is you extend one config you want, and then you extend this one at the end, and it will disable all the rules that are related to formatting and will replace them with one rules that are Prettier related. So all the useless formatting rules that ESLint have baked in will be disabled, so you don't have to go through your config and change them one by one. Plugin Prettier basically adds new rules that are based on what Prettier will actually output internally. And also it will enable us to run ESLint fix and run Prettier under the hood for the file that is getting processed. So it's pretty great. As what I said, it's you can use it standalone or you can use it integrated with the ESLint pipeline, and it's what we're going to do. And of course, we need to install Prettier, and we're installing ESLint too. These apps, these command line interface apps that we are going to use, and this is just a setup for them. Next thing, we should definitely run npm install. I already ran it, so for me it will not install much of any things. Next step, we will have to add ESLint rc JSON. So ESLint rc JSON is basically a file where you describe your config for the project, ESLint config for the project. And another file we need to create is .prettier rc JSON, same thing. And the rules will be for our ESLint will be like that. So we extend React app config, we extend Prettier config, we extend plugin of the Prettier, and the only thing we set is one rule is Prettier and warn. So everything unformatted will be yellow in our editor, so we will clearly see that our it requires some love from the Prettier so it can be formatted properly. And the setup for Prettier, I mean, you can keep it as is. You can just ignore setting up anything for Prettier, but I prefer this one. So print width will be a bit wider than usual. Usual is setting 80, and I think it's too narrow for the code. For the text is perfect, but for the code is not. Semicolons, I'm switching it on, so it'll print semicolons. Usually I don't have them, but for the React Hanger original repository, we have them on. Single quote means we will use single quote and a double quote in JavaScript, and in JSON you should have double quotes. You cannot use the single quotes at all. And trailing comma, so we will have a trailing comma like that in a JavaScript expressions. The next thing we should add is a couple of npm scripts to our package JSON file. So what we're going to do, we will go to the package JSON. And before the dependencies, I prefer to have them here. We will add scripts, right? And okay, it's already there at the top. So let's use this one. I will just move it down a little bit. I'll remove test for now because we don't need one. And I will paste in scripts. So what it does, we have a command that is lint and lint fix. So ESLint source directory only. We don't have this directory yet, so we can just create it if you want to. You can ignore it. And max warnings to 0. What it means that every warning will be acting as an error, basically, because I just don't feel it makes any sense to have ESLint warnings to be warnings and to keep them in your code base. I think your lint run should be absolutely clear without any warnings. If you have warning, you better ignore it, and tell in the comment above the ignore why would you do that. And another command will be just npm run lint, and then we pass fix. So imagine it's like run like that. So fix, what it will do, it will basically format the code and will fix all the possible rules of ESLint that are fixable. If you go to ESLint page and see the rules, I think it's somewhere here, so rules, you'll see that few of them are fixable. As you can see, the fix option of the command line automatically fixes problems. So if you scroll down, you see that no regex spaces, there's allow multiple spaces and regular expressions is fixable automatically, and few others here. So all the rules in Prettier are fixable, of course, because Prettier will run and fix them. And this is what we will have here. Another thing that is nice to add is cache. I think the latest version of ESLint, 7th version, it's a new thing. So if you will run it with a cache, it will basically create a file in the root alongside the place where you ran it. And it will use this cache for the next run. And this run will be way, way, way faster. Okay, we should run it right now. I'm not sure it will work properly because we don't have any code, and it will complain about that, right? So no files matching the pattern source were found. So it's actually running. It's all good, but since we don't have any code, I think it's complaining. So we can create the index.ts files, just so it's kind of happier about that. And let's try to run it again. Okay, I did something wrong here. Okay, so let's run npm run lint. And again, it fails. And what's the reason about that? It's because it declared an ESLint JSON cannot find TypeScript. Yes, because we forgot to install TypeScript. So here we go. Let's add TypeScript here. And let's install it, of course. Let's run clear and clean up this console. Clear and npm install. We'll install TypeScript real quick. Clear again, and now it will run just nicely. Install lint. Everything is great. So it ran. There's no issue. Of course, it says the warning that this TypeScript ES3 version only TypeScript version 3.10 is supported, and my version is 4.05. So I have to update these dependencies in order to get rid of this warning. But I think it's all good for now. Yeah, I will bump the versions, so the resulting code will be different at the end of the day. And you may just copy paste this one from the resources of this lesson. So as I said, I bumped the versions, so you can copy paste that, or you can just type it in if you want to waste some time. So let's just run it and I will prove you that everything is fine and everything is green. As you can see, all great, no issues at all. I'm running, no problem. It may probably tell you that it cannot detect React version in your dependencies, and it's absolutely fine. We're going to install the React dependencies later, and this warning will disappear. But for now, it's all great, and it's all working, and we can go to the next lesson right now. Okay, so this is the guide on how to set up ESLint and Prettier for the WebStorm. So let's write some code, right, and see whether it complains. So as you can see, this should be, it's not unused, it's unused constant, and it's just WebStorm that is complaining here. So we want it for ESLint to complain here, not IntelliJ or WebStorm. So what we need to do, we want to go here. We need to first enable Prettier here. You will find it out. I mean, it was already there, but I just want to know that you can use the search thing here, and it will show you right away what you want. Then, if it's not already out of pre-populated, you should select your Prettier from the node modules that are here installed in your package. Then you need to use the glob pattern. You can learn about glob patterns, how it all works here. So the glob pattern we have here is pretty good. It will match all JavaScript, TypeScript, JS6 and TS6 files. Then you want to keep this thing enabled, or you can enable it if it's not. This will enable Prettier for all Ctrl-Alt-L, typical command for formatting the code in WebStorm Windows. To actually format it with the Prettier, you don't want to have Prettier run on safe, and I'll explain you in a second. So next thing we want is to enable ESLint integration. So let me open it up. It will be disabled by default, and you should just should select automatic ESLint configuration here. And then here you will see run ESLint fix on safe. And this is exactly what we want. And since we don't want to conflict, I mean Prettier, we don't want Prettier to conflict with ESLint on safe, right? We don't want two things to run and fight with each other. You better have ESLint on safe and Prettier on code reformat. That's a bit more reliable, I would say. Also, one important note that ESLint is actually, the Prettier is actually working with Markdown files, HTML files, and CSS files. So you can also extend this one with Markdown and CSS if you want to. We're not going to write any Markdown or CSS files in this course for sure, but just for your information. And then we apply and we press OK. And let's wait for a second, and you'll clearly see that it's all working. Oh, as you can see, right now it complains that, first of all, we are not using double quotes, we use a single quote. And another thing, that A is a constant that is not used. So ESLint is complaining here, not only IntelliJ. And let's just do some unformatted stuff. As you can see, it's not happy anymore. And then I click Ctrl and S, so it saves. As you can see, this is fixed, which is great. And same with editing, right? So if I will do it again, and I'll press right now Ctrl-Alt-L, it again edits it using Prettier, and everything is working pretty good. So that's it. So right now, I will show you how to set up ESLint safe, fix ESLint issues on safe. And as you can see, I just installed Visual Studio Code. So it's not super prepared video, but I think it'll be helpful anyway. So as you can see, since I'm using VSL for Linux, it asks me to, just use it. And it probably makes sense because Visual Studio Code is managed by Microsoft. So they have the best integration with VSL, it seems. So let's install this extension. Great. We have removed VSL, WSL. It's all great. And we install it. Probably it will ask me to reboot, maybe not. Next thing that is definitely needed is Prettier, Prettier extension. As I said, I'm not super hardcore user of VSCode, but I still know something. So let's install Prettier here. All great. I think it's an official one. So as you can see, it's 9 million of installs and it's pretty supported. All great. Next thing will be ESLint. ESLint. We want the clear one. We don't want this one, a mixed one. Original one, so installing it. All great, beautiful. So our extensions are there. Let's remove anything from searches. And popular, and installed. Is there that installed? Of course. So we have 3 of these things installed and it's all great. Let's open the folder in VSL. I think we should go here, Ubuntu in my case, then home, RIP21. That's my nickname. Pretty weird. So here's the React Hanger course folder. As you can see, everything is beautifully open. We are good. We can see the files. Awesome. So the next thing we want to do is to set up this automatic fix on save. Okay, so the best place you can go in order to understand what to do with that is to go to the documentation. And I already have it open before. So for the Prettier, it's pretty straightforward. What we need to do is to add these options into our settings JSON that VSCode is having. So let me copy paste this. Let's change settings JSON. Open default settings JSON. Great. So, okay, this is what I really want. So, okay, wrong copy paste here, and we copy paste in this thing. All great. Okay, next thing would be is ESLint, and we definitely want to edit our code actions on save. And currently, do we have anything currently? Currently, default formatter, Prettier VSCode. So probably we just need this to be on. And let's add it here. Okay, it's complaining. Code action kinds to be run on save. Expected comma. Here, of course, comma should be here. Let's save it and let's check whether it will work for us. So we have this thing. ESLint is disabled since its execution has not been approved or denied yet. Use the light menu to approval. Okay, so pick a problem. And what can I do? Manage library. Allow everywhere. Allow everywhere. So it's allowed now. So as you can see, we have an issue from the ESLint. We can clearly see it. It's beautiful. It's working. So let me make a lot of spaces and save now. Oh, it's working beautifully. Okay, another thing. Let's just go here and run code formatting. I don't know the shortcut for that in the VS Code. So let's try format document. So it's Shift Alt F, and it worked. It seems that it all working perfectly and nicely. And this is how you do it. I just did it just by Googling, and it's amazing. And you should do too. Okay, so the next step that we're going to do is to set up TypeScript. If you're not familiar what TypeScript is, and probably if you're not familiar with typed languages, then it will be a completely different topic for you and you'll have to Google about that. But basically, TypeScript is just JavaScript that is enriched with type constructions, definitions, whatever to the language, to the TypeScript language. That is, I mean, every JavaScript, mostly in 99% of the cases, is valid TypeScript. So it's just kind of a superset of JavaScript. JavaScript is great if you have small project, right? Or you have a small script to write, you will just hack it around really quick. There's no compilation errors like if you ever programmed in the C++ or in the Java, you will immediately hit this block and you will have troubles even to start the program. While with JavaScript, everything is running, right? So it's pretty forgiving, etc. But TypeScript gives this strictness that definitely helps experienced developers and definitely helps scale JavaScript codebase further. If you're not sure what TypeScript is, I highly recommend you to read through this website to understand why would you need this one. And, read the docs, the handbook, the community is great. There's a playground, there's a lot of tools. So yeah, this is it for the, super short introduction to TypeScript. So let's install TypeScript dependency, right? So what we need to do is to run typical npm install TypeScript and d. So we install it to the dev dependencies. Okay, all right, let's double check our package.json now. So here we go, we have a TypeScript running. So great, and the next thing you should have in order to make TypeScript working is to have a tsconfig.json. Great. So it's pretty tricky to find a good config usually and to understand what kind of setup you want. So let's say open the docs, and definitely there will be documentation about tsconfig. So what's tsconfig, right? There's a lot of stuff to think about, right? There's a lot of problems with it. Like what should I make true, what I should make false, etc., etc. It's pretty complicated. Just to avoid this complication, you can definitely go and read about it in tsconfig reference about every single possible setting that you can use. But it's for super advanced or legacy code bases usually. So the greatest place where you can actually go and check and steal great TypeScript config is this repository named tsconfig bases. And here we go to the bases, we go to the recommended, and we're just going to copy paste this one and paste it in here. Okay, it's happy now. I think display is not used much. What I want to add usually is root directory and base URL to be source. So because our code is in the source, so I want it to be relative to the source. What else? I think it'll be great to add a library. And here we want to have a yes next. So we support the latest features of the language. This is how it's supposed to be. And I think that will be it for this one. We want to generate not CommonJS modules, but ES6 modules. Target should be also ES6. We may change it later. And we're not going to use any JSX, so it's all fine for us. And definitely we don't want to emit anything. So another thing we want is no emit to set to true. Also, we probably want it to include only source directory. All right, so the last step we need to do is to add a TypeScript command here, just so we make sure it all works. So let's everything is great so far. Let's just run it now. Yeah, everything is working great and it's up and running. Let's just break something, right? Let's make a const of string that will be of type of string, and let's pass a number here. The type number is not assignable to type string. So as you can see, we have a number and we have a string. It's all working. It's all great. We're happy about that. And we can go to the next one. So in this video, we're going to set up our testing framework. We're going to use Jest. It's a project that is supported by the Facebook. Once again, it has a great support, great community. I think it's the biggest one for now. Almost zero config. Of course, you can set up a lot of stuff there. It has a great API. It runs tests very quickly and fast. You can do the coverage. You can do the mocks very easily. There is a lot of matchers. There's a great reporting. When there's a matchers or fail, it will nicely show you the results. And, that's a great tool that we're going to use. That's a great piece of software. It has a lot of plugins. It has a lot of, matchers, reporters, extensions. It works with all kind of continuous integration systems. We're going to talk about it later. And, it's just great. So let's just set it up. So first thing, as usual, we need to run our npm script to install it. So npm I for install, then we do d. So we will install it for the as a development dependency. So we need TypeScript Jest because we're using TypeScript. Then we need types for Jest, and we need the Jest itself. Here we go. All right, so we have it. And next thing we need to do is to run one simple command, which is npx TypeScript Jest tsjest config init in order to generate jestconfig.js file. Here we go. So it's pretty simple, straightforward. Preset tsjest test environment node. Okay, so the next thing we need to do is we need to add the package JSON test command. So we'll have a test command, which will just run test, no, not test, jest. Then we will have a test watch, npm test with watch flag is exactly the same thing as running it like that. Let's just create one test file just for the sake of making sure it's all running. So test yes. You need to have this postfix of test ts or test js in order to show just that this is a test file, it's not a regular JavaScript file. And let's just write some simple test. So here's a simple test, and let's just run the command. So clear npm run test. As you can see, it's detected, our test hello world is passed, and everything is running smoothly. That's not all that I want to add. There is also ESLint config that will be a nice addition. ESLint preset or plugin, whatever, that'll be nice to add to our beautiful ESLint config. So let's install it first, as usual. Great, clear. Next thing, we need to add some stuff to our beautiful ESLint config. So let's just copy paste this thing. Great. And then we need to add a plugin, jest here. And we need to add environments. So globals to be true. So, and I think it's great for us and it will work for us just fine. So congratulations, yeah, we just ended our initial developer environment setup and we are ready to finally develop custom hooks. If you're not interested in this part, you can just skip it over to the module 3 and to get straight into the how to prepare your code for publishing, compiling, bundling, and stuff like that. All these in-depth details will be in the module 3. Module 2 will be solely about hooks, not in depth, but just implementation details of how React Hanger is working under the hood. So it may be interesting for you, or you may just skip it. Let's go to the next one. If you're a familiar user of React Hanger, you may notice that some of its hooks are having two different APIs. One is returning array and another is object. What is a big deal, you may ask? One of the good rules when you're developing certain custom hooks APIs, mostly those that are holding and exposing some state, is to keep them as close to original React hooks API as possible. So let's take a simple example using use state, right? So what do we have here? We have a component of open close sign that renders open or closed depending on isOpen state, whether it's true or false, right? All clear, but there is a little of boilerplate needed in order to keep reference equality of toggle open callback between re-renders. So our children components are not re-rendering for no reason, because, you know, if you change the reference for the React, you know, it will just compare two references. And even though toggle open is exactly the same as it used to be, you know, it will still re-render the button or any other component that will be here. We definitely want to avoid that. That's why we have this use callback hook that is coming from the React. That will make sure that this toggle open will never going to be changed between re-renders because there is no dependencies, because here you can pass the dependencies of this particular callback. As you can see, it's saying, you know, deps. But since there's no, we are absolutely safe, and this reference will be the same all the time. So the components that will get this callback will never trigger the render because of this callback. So pretty complicated, I know, but I mean, I hope you'll get to understand this one. All right. One important part of every single snippet you see in my screen is that this initial state, callback, boolean, value, etc., it's not a code. It's not a code, so you should ignore these gray thingies because it's basically a suggestions, hence that IntelliJ or WebStorm is showing. So I can just disable that, but I prefer to have it. So just keep it in mind that you don't need to type it and that it's not a piece of a code here. Right. So This snippet can be improved using custom useBoolean hook from React Hanger. And we're going to implement this one in the next lesson. So check this out. So as you can see, it's way shorter. As you can see, there's way less code to type. And useBoolean is already kind of keeps it all nice and clean and without any additional boilerplate. So you're saving the boilerplate. Nice, right? And it's pretty same as useState. So you have isOpen thing, you have isOpen actions, and these actions have a toggle function that basically toggles isOpen state from true to false, from false to true. So everything is working nicely and beautifully. So yeah, it's pretty obvious API. It feels like it's a part of React itself, even though it's not. So state on the left, everything that is changing state is on the right, all the callbacks, setters, methods, etc. It's intuitive. And let's check out another example. I'll have it here on the right. So same component, and let me change the scratch, but another API. It's an original API of React Hanger from the version 1. In the version 2, there is already also array 1 that we've used before. And this one is, not that straightforward because it returns object here, and we have to destructure this object into the isOpen and toggle open, and we need to rename value and toggle so they are not unnamed. We can definitely remove this one, yeah, but we want to rename it because it makes sense. And same for the toggle open, we want to do the same thing. So still pretty straightforward, right? You can read the docs and you will immediately understand the API. But array 1 is more, React looking, and as you can see, this one is pretty clear, and this one is not that clear, to be honest. So let's take a look at last scratch. These are two APIs, right? And what's the worst about the object API is that it looks like they're pretty much identical, right? But they are not. In the first snippet at the top, you can pass all the actions as a whole and separately without unnecessary renders because they are memoized under the hood. And the same reference returned all the time. So if you will pass this whole show header or show footer actions to the other component, everything will be all right because all this thing is memoized, right? And they never change the reference. And in the second one, we're taking the value out of the returned object and spreading the rest of the object properties that represent our actions into show header actions. So as you can see, we have a value on the left. Everything is all right. It's a Boolean type, so we will not cause any re-render. But these are same thing as here, show header actions or show footer actions. But the problem here is that when you do the destructuring here, you actually create a new reference every single render, which causes unnecessary render. And it's not really cool, and it's not that obvious for the user, to be honest. Not everyone knows internals of JavaScript that well to understand this small issue. Of course, you can then restructure it yourself, and you can do what we did before. So it'll be toggle, etc. But it's a lot of typing, and we definitely don't want to do that. So the main conclusion here is that Array API is better because it feels closer to React's use state. Hence, it's a bit easier to understand. It always returns the same reference for all actions, avoiding unneeded renders of its children. And it's just slightly shorter than object version of API. So with that in mind, let's implement useBoolean ourselves. Okay, so let's implement useBoolean hook. Before we start, we need to install React library. Let's add React as a dev dependencies and as peer dependencies. Okay, let's do this manually this time. So here we go. And peer dependencies. Great. And let's run npm install. Great. So know that once this library will be published, right? If we publish this one, React will not be installed automatically, but will require consumer of the library to have version of React at least no lower than 16.8.0, which actually adds support of React Hooks API. And one thing I forgot to add is types. For the React, I need to install it too. Let's sort it and run npm install. Okay, so once we have React installed, we can start implement our first useBoolean hook. Let's create a useBoolean TypeScript file inside array folder. So let's go here, create an array folder, and let's create our first useBoolean file. So let's create the useBoolean function type with signature of the hook API we want to get. Let's start with the function itself. So we are importing everything we need for our implementation from the React useState and setState action type. And the signatures look like that. So useBoolean function will take initial as a Boolean, initial value as a Boolean, and will return Boolean and useBoolean actions. Pretty straightforward. Let's add the useBoolean action type. So actions will be, just 4 functions, 3 void functions. That one is just, you call it, it toggles the Boolean value of useBoolean hook. Set true will just set true guaranteed. Set false will guarantee to set false, right? And we also need to export useBoolean type for our users so they will be happy. Okay, so let's go to the implementation itself. Here we go. It's a pretty naive one, so let me walk you through all of it. So first thing, right? This thing. useBoolean, going to return useBoolean function that we have here at the top. Then we have initial, that is supposed to be Boolean. It's great. We have autocomplete here. So this one will have a useState of with the generic type of Boolean. So this initial should be Boolean, otherwise it will argue with us. We also have toggle function, set true, set false, set true, set false, pretty straightforward here. Toggle will flip the Boolean value using this exclamation mark. And we need a callback here just to make sure that it's reliable. The flip will be reliable. So if we will call toggle 3 times in one function or something, it will reliably make it true, then false, then true. Because if we'll just make it like that, it will probably fail and will return some weird unexpected number if you will call toggle 4 times. So you have to do it like that. It used to be like that with this set state, and it's still the same thing for hooks. Okay, and then we have an actions object where we paste all of the functions that we want to return, and we return this beautiful array with first thing is value and second thing is our actions, and we export the function itself. All right, so in order to test it, I will use good old copy paste and a beautiful project named codesandbox.io to test it just in the browser. I already have it open here, so let me create a sandbox, and it's going to be React, but I would prefer one with a TypeScript. So let me try React TypeScript. Here we go. All right. And let's just paste in here. Okay. Index, it will run. Okay, it will just import it as a default. And as you can see, it all renders. All great. So let me check how it works. As you can see, it's all working well. Everything is fine, but there's one thing I want to show you that is wrong with this optimistic and straightforward implementation. So let me show an example. Let's create a component that shows timestamp of its last render. So here we go. We will name it a dummy component, right? And what we're going to do is, okay, let me zoom in a little bit here. Yeah, so here we go. We have a dummy component, and we're going to render it right down here. All right, as you can see, we have a milliseconds since epoch time, so all great. And as you can see, if I will right now trigger toggle multiple times, this thing will not re-render for now, right? Everything is great. Everything is awesome, right? But if we'll pass here some properties, like our isOpenActions, right? So on click, even though we're not going to click, but anyway, isOpenActions toggle. All right. And I'll click on this one. As you can see, it renders every single time, even though actually it shouldn't render, because honestly, this toggle function never changes. I mean, it's the same toggle thing that does the same thing, and it should never change. So it's what I've been talking before. You have to wrap all this stuff in a use callback in order to make it optimal. So let me go back to code and do that. What we need to do, we need to wrap all these guys into use callback, and it will be pretty happy after that. So let me do that. All right, this is need to be imported from the React. Great. And let me copy paste this piece back into our beautiful sandbox. Here we go. Okay, and to replace the React import here, like that. All right, let me remove this export here. And let's click. As you can see, after these changes, dummy component is never gets re-rendered because toggle never changes. And it's all great, but there's another case that is broken. So let's imagine we pass whole thing into the dummy component, right? isOpenActions, whole object. And if we run, as you can see, it will actually re-render again, which is annoying. How can we fix this? So simple, we need to wrap this object into the useMemo function. So let me just do it. Here we go. So this is how it all looks. We have actions, we have useMemo, and we have this beautiful object that's going to be returned only and is going to be changed only if this set false, set true, and toggle change. But since these guys will never change, as you can see again, actually we can remove this, but it will make our ESLint rule to complain, saying that it has missing dependencies because it's not that smart. So let's keep it, and let's just copy paste this small piece of thing and see how it fixes everything. The whole useBoolean function, paste in. It will ask us to import useMemo. All right, and as you can see, now every re-render does not trigger re-render of the dummy component, and it's awesome. Great. In the next lesson, we will write unit tests for all these use cases to speed up our development. Copy-paste is all good, but we better automate our tests. Alright, so first of all, we need to install all needed required dependencies to test our hooks, plus we need to delete this useless index test TypeScript file. Okay, let's just delete it. Alright, so the dependencies we're going to install will be the testing library React hooks, and testing library React, and also the React DOM, because this one is needed in order to render something to our fake JS DOM. I think it's a requirement here, and let's just sort this thing nicely. Good. And run the installation. So yarn or npm install. All right, let's clear the console. All right, let's give us more space here. Okay, so why these two libraries, right? So first of all, about testing library. If you're not familiar with testing library, set of libraries, they are basically a set of wrappers around DOM selectors and other custom selectors that make testing more user behavior centric. By user behavior centric, I mean It's API designed in a way that if you select your components, you're not doing that by, React display name or plain good old CSS selector, but by using more user-land terms like find by label or find by text. So all tests are really look like a real high-level user interaction scenario. These scenarios are way more important to the user and hence the developer than the implementation details that are not really that important for you to sleep calmly, right, on this Friday evening production deploy. So in other words, it's focusing on making your tests give you some confidence, and actually that's the main purpose of the test, to give you confidence that your code is still not degrading to any sense and working perfectly. Also, since implementation details are not actually important for us, right, because we are testing the user scenario and we select stuff using user land selectors and stuff like that, we can even change our underlying framework. So let's say React to change it to Svelte or Svelte, I think, or to the Vue or whatever. Of course, you'll have to change some, beginning of the test, how you render it, but the rest of your selectors, you will be able to just, keep them as is. And if you do one-to-one application, it will just continue to be correct, and all your test cases will be kind of logically correct, and only a few things will have to be changed. And it's really great. It's golden. And if you're still using Enzyme for testing React components, I really recommend you to move towards testing library React. Okay, so although if we're testing the functions, meaning we make unit testing, right, and not integration testing that we've been mentioning before, we need to go down to the role variables, reference comparisons, etc. In case of hooks, when you test them, the problem is that you have to use your hooks inside of your components, React components. And for that purpose, at the very beginning of hooks, when it's only was released, you had to create dummy components and do some tricky stuff to actually check whether stuff got changed, etc. And it's super clumsy. So to avoid all that and avoid rendering dummy components, we're going to use testing library React hooks package, which is essentially a set of helpers to test hooks in isolation, like to unit test them. I recommend, as well as the authors of the library recommend, that to use it only for highly reusable hooks, or hooks libraries like the one that we're trying to do right now, like the copy of React Hanger now. So in all other scenarios, you should test whole component instead by just using whole testing library React, because you really care about what is getting rendered and not the actual, implementation of the hook itself that is used in some particular component. Okay, so I think I cleared everything up here, and let's start actually writing the tests. Okay, so let me create a file named useBoolean test.ts. useBoolean. All right, and let's actually put it in the tests directory, so it's nice and beautiful. Okay, and let's start with our describe block first. Okay, now let's write our first case inside the describe block, right? So let's check that if we call the setTrue function, it will actually set true our state, right? So let me just do that. All right, and let's just import render hook and use Boolean from our beautiful array useBoolean function, and act. Let's import it from React hooks as well. All right, so this is how it all looks. Let me explain step by step, right? So first we render our hook, right? Using the helper function render hook from React, from testing library React hooks. It then returns the result here, which is basically, as you can see, is a Boolean useBoolean action. So exactly what we called here will be returned, but it will be returned because, as you can see, it's wrapped in a hook result generic function, generic type. It will be a ref basically. So in order to access these two things that our useBoolean thing is getting returned, we need to call the current thing. So okay, we ignored the state here, and we just care about the actions. And what we are doing here, we say like expect result current 0, so our state to be false, and then we do set true. So we wrap it all in act, which is important, and then we assert that our state has changed to true. You may ask, why am I not just here have a state, right? And then assert against it. And the reason is because then the state will be, it will not change. It will be, if it was false, let's say at this stage, it will stay false at that stage too. But if we're using current, we actually using a ref, and ref will be changing after the acts, etc. So if we will call it like that, we will get the actual value of our state. Okay, so it may be confusing why I'm wrapping stuff in act, but it's really hard to explain maybe, but in short, if any action or function call like that you're going to call inside your test is going to change the React state, then you have to wrap it in the act. What it does is basically tells to the React that all state changes should be flashed back to your DOM before doing any assertions. So because the React currently is absolutely asynchronous and it's a lot of magic happening here underneath, they created few helper functions to actually aid your test running and all these processes, asynchronous processes in some way, so you can actually hint him like, can you please flash all the state changes before I run any other code? And he said like, okay, surely, everything is flushed. You can continue executing your assertions, and then you check it, and everything, if everything is rendered, the changes will be here. Okay, so very important to mention also is that most of the functions that are inside the testing library React are already wrapped in act. So stuff like fire, change, or all kind of interactions, etc. They are automatically wrapped in act, just in case. So it will be nicer without all these callbacks, etc. But sometimes you have to just use the act explicitly, and it's absolutely fine. All right, so let's test the rest of our functionality. So let me copy paste a little bit. Here we go. So pretty much the same function that will check that false will be set. Nothing different much. And the toggle one, again, we start with the true. Then we double check that it's still true after we render this. Then we act to toggle, it changes to false. Then we act and toggle again, it changes to true. So let me run the test so you can clearly see that everything is green so far. So npm test. Okay, failed. And the problem with all that is cannot find React test renderer. Great, so I forgot one dependency, so let's add it. It's pure dependency of testing library React. Let's install it. And sort. Beautiful. Okay, let's run it again. Great, something failed. Cannot find module array useBoolean. Makes total sense. Let's just call it like that. two things. Call it again. All right, so everything is great, everything is green. Next step would be to actually check something really important. The one thing that we've been discussing in the last lesson is all this reference equality. So we are avoiding all these unnecessary re-renders for no reason. So let me do that. All right, so here we go. Let's do another describe block inside here. And let me explain what's happening here. Let me just make this terminal smaller. So here we go. What's happening? Again, we are rendering our useBoolean hook. Then we save our original actions reference. As you can see, that's the original actions reference. We then destructure all these actions. And what we're doing, we actually check that everything is matching, that original is original, and everything is great. Then we act. We do set false. It could be, set true too, to be honest, but set false will guarantee to change our state. So it means that our dummy component that is used under the hood in this render hook will be re-rendered. And if something is getting re-rendered and you're not handling your references properly, you will have different references, hence unneeded re-renders, or use effect will be triggered for no reason, etc. So you need to minimize properly. And then what we're doing, we take our original references here and we just basically compare them to what is actually there in our reference, in our ref, in our current, after this re-render. And if they are matching, means our minimization is correct and the references are the same. So let me run the test and see if everything is great. So let me clear this mess and let's run the test. Everything's green. So let me break it just so we are sure that we actually testing something, right? So let me do it like that. Let's remove the callback. So false should actually get broken. All right, no complaints. Yeah, it's actually tells me that it's going to be changed every single re-render. It's actually nice that it's immediately tells me that ESLint. But let's run the test so I will prove you. Yeah, as you can see, it's failed. Well, it says that object equality. So they serialized the same string, right? Exactly the same, but their reference is different. That's why this assertion is failing. And as you can see, it's failing exactly on our original actions reference, because our original actions reference is actually changing every render, because here this thing is getting changed. So the actions are getting changed for no reason. So it's actually failed even before the set false thingy. So let's revert it and run it again. Everything is beautifully and everything is running. And as you can see, we can save a lot of time by not going to a code sandbox and check how our dummy component will behave with different set of actions or just functions or just state, etc. So it saves you a lot of time. So that's it for our useBoolean testing. And next up, we will implement our useMap hook, which will be the wrapper around the map default JavaScript data structure. And yeah, we will be using TDD, so test-driven development. First, we will implement the tests, and then we will implement our useMap function. That's it for this lesson. Go to the next one.